Good evening, everyone. A very warm welcome to all the participants. I'm Saryu from S. Chand Publishing. Today on 19th May, I welcome each one of you on this second last session of Maths webinar under the CPD training initiative by S. Chand Publishing. Now, before we start with our session, a quick reminder that on 20th May, that is tomorrow, we'll have a quiz based on all the 6 sessions. So with exciting prizes, so please try to attend all the sessions. Now, coming to today's session, the topic of today's discussion is use CPA approach to deepen mathematical understanding, part 1, by Ms. Jaspreet Sethi. Jaspreet ma'am is a maths expert and holds master's degree in mathematics from Columbia University. She is a LETRS. Just a second. She is a LETRS certified. LETRS stands for Language Essentials for Teachers of Reading and Spelling. She has also authored a series of children's books. Ms. Jaspreet has not only taught maths at some of the prestigious schools, both at national and international level, but also has served as the department head in different schools and has been a member of advisory board for different universities. So before we start off with our session, there are some ground rules that all of us have to follow. All the participants will be put on mute throughout the session. Please keep a pen and paper with you to note down the information and any questions that you have to ask. The chat box will be enabled only during the question and answer round and will be disabled for the rest of the session. For each certificates teachers, you must fill the feedback form, which will be sent to your registered email ID. Now, I welcome you, Jaspreet ma'am, to this session, and we all hope to have an enriching experience with you in today's session. Over to you, Jaspreet ma'am.
Thank you, Saryu. Thank you for the warm welcome. Good evening, everyone. Hello to everybody in a different time zone. And as we have always, we are going to start with a game. So let's play before we dive into Concrete-Pictorial-Abstract, which is for today and tomorrow. So for let's play, for this one, usually it'll be nice to have a pen, pencil, paper around. This one has a couple of steps, so you may need to write down. If you have a phone handy, you may use your phone. It's okay. So here are the steps. I'm trying to guess your birthday. I'm going to go through a series of steps for that. I need some information. So the first one is to take the month that you were born in and multiply that with 5. So the month you were born in, for example, I'm born in the month of September, then we are taking 9 and multiplying that with 5. Whatever your month is, multiply that month's number with 5. Add 17 to that result. Double the answer. Doubling the answer means whatever you've received, either multiply by 2 or add with the same result that you got after you added 17. Subtract 13. Next step, multiply that result with 5. There are 5 more steps to go. So you took your month's birthday, multiplied with 5, added 17, doubled the result, subtracted 13, multiplied with 5. Then you subtract 8 from that result, double that result, add 9, and add the number of the day on which you were born, for example, 23rd, so add 23. And then subtract 203 from this result. If any of you missed this really quickly, I took the month that I was born in, multiplied with 5, added 17, doubled the result, subtracted 13, multiplied with 5, subtracted 8, doubled my result, added 9, added the day that I was born on, my birthday, and subtracted 203. I'm hoping if you've done the math correctly, all of you are able to see that you are seeing your month and the day that you were born in the result. I'm going to walk you through the steps on what is really happening here. So you may have seen this and you may have done this with people, but what really happens when we do these kind of puzzles, what we're really looking at, I think our chat is open this time, right? Saryu? Thank you. Good evening, everyone. Good afternoon.
Yeah, I thought that it's a question and answer round, so I had enabled it. But now
Yeah, well,
again,
if anybody wants to reveal their birthdays and write down whether they have received.
Yeah, I have received it.
You are able to see your birthday there.
First is the month followed by the date.
Perfect. So of course, there's no magic here. It's basic algebra. What did I do? What's the maths? I took the number of months that I was born in and I multiplied that with 5. And then I added 17. I'm showing all this using algebra, and then I will show this using a result, for example, my birthday. And then I doubled that. So that was 2 times 5n plus 17, which distributive property is 10n plus 34. That is multiplying the 2 with the 5n and 2 with the 17. Then I subtracted 13. So I still had 10n, but plus 21 because that's 34 minus 13. Then I multiplied that result with 5. Again, I'm using distributive property. So I'm multiplying 5 with the 10n, which is 50n, and 5 with the 21, which is 105. Then I asked you to subtract 8. I got a 97, 50n plus 97. I asked you to double that. Again, distributive property. So that's 100n plus 194, which is double the 97. And then I asked you to add 9 to that. So that 194 becomes 203. So I was being very strategic there because I had asked you eventually to add your birthday and subtract 203, that 203 that I got here as a constant. And I have plugged in my birthday to show you that it worked for me. If I did this all correctly, and I plugged in n as 9, which is my month, September, and I added 23 to that, which is my day, I'm anyway looking at 900 plus 23, which is the birthday. And that from that 203, I'm subtracting the 203 anyway. And all of you would be doing that. All of you are subtracting 203 minus 203 if you break down the math. And you get the month and the day. And of course, it's evident that I took that information from you when I asked you to multiply the number of the month and I asked you to add the number of the day. So no magic there, pure math. And why I am doing this? Of course, we play every time. That's just me. That's just the way I begin my sessions, my classes. But it's also today to take you into a world where all of this, all the math I've done here, looks abstract to our children. And we need to work backwards to make it more relatable to them. So we're going to be talking about Concrete-Pictorial-Abstract and that journey. In doing so, you will get a lot of ideas and examples. And tomorrow I'm going to take on some more ideas and examples specifically. But first, let me introduce you to the world of concrete and pictorial. A lot of times there's this misconception that concrete means you need to go and purchase some materials which are expensive. And maybe, it's not economical, it's not sustainable. Actually, I'm going to try my best to kind of balance it. Yes, being a math person, I have traveled also the world. So I have collected a lot of math manipulatives, a lot of puzzles, a lot of things on the way that have helped me grow in the maths that I know and I deliver. But at the same time, I have worked with a lot of schools where the resources are low. And it comes down to teachers to use their own resources or to be creative and come up with ways in which they can duplicate those concrete materials using sustainable resources. So I'm going to try my best to kind of cover all of that. Before I do that, I want to remind you that on the first session, and every session I'm kind of doing this reminder, that it's a big responsibility to be a teacher. The tone, the culture, the warmth that we set is something that our students take in their heads for life. So it's a big responsibility. Kindness to ourselves, to our students is really important. Nobody is trying to be annoying or lazy. Maybe we are boring them really. And sometimes it is truly that they need help and we need the tools to help them. So kindness in all that we do. We're trying to make this a better place. We're trying to make the field of education, the field of parenting, the field of childhood a better place. And there's something known as a math divide, which sometimes comes in the way of all these things. And what is the math divide? It is that students will not connect with and pursue math when they lack all of these 10. Everything I've underlined is something that I've actually taken up in my sessions. And that's why it's almost green now, because I'm hoping that I'm trying to address all of these in the sessions that I have taken. And even today and tomorrow, I hope to bridge any other gaps that you may see. Even then, I will, of course, not cover the spectrum of math and the full, the entire rainbow that math is. But I'm hoping I am sparking some ideas, some innovative strategies for you to take back. So week 1 was using stories to teach math. Week 2 was addressing and alleviating math anxiety in the classroom. And today is using CPA, Concrete Pictorial Abstract. So what and why do we use concrete pictorial, and how does it translate to abstract? And how do we use it, and what are some resources and tools? And you're going to see some CPA in action today. Tomorrow, we're going to look at some more CPA in action, Concrete Pictorial Abstract, and we will have a quick summary and some takeaways, hopefully, from all of you, contributing to letting me know if this has been of any help to you. So what, why? Let's dive right in. Concrete would mean handheld, tactile, kinesthetic. There's something that our children are able to grab and hold, touch and feel, and they're tangible usually, so that whatever they do with their hands leads to experiential learning, which transfers to long-term memory. So some of the concrete materials, one which is so overlooked, are our hands. So we're going to talk about our hands, which come under the category of physical or virtual manipulatives. Of course, some other concrete tools would be physical objects other than your hands, measuring tools. Sometimes we count things, sometimes we measure things. It's not always easy to count everything in the world. So we measure some things that we can't count. So we need measuring tools. Nets, we'll talk more about that. Strips or bars are more concrete tools. Sometimes these are also used in pictorial format. If any of these go into the form of 2D, and I'm showing it to you visually, at that point, it will all become pictorial. But pictorial is beyond concrete, so we'll talk about that as well. Hands, so underused, and feet for counting. And we have access to these, our children have access to these, and our young ones who are very small and they are not able to open their fingers to show 1 or 2. It's a little hard for them to do it. I use these hand cutouts, and it's easy to then fold the fingers to use them for counting. And it's not just counting 1, 2, 3, 4, but it's also to understand partners of 10, which is very fundamental in early math development. Partners of 10 would be, when I show my hands, I'm showing 0 and 10. But then when I fold one finger, I'm showing 1 and 9. And then I'm showing 2 and 8, 3 and 7, 4 and 6. So like that, I'm showing partners of 10. I think I was not showing 4 and 6 correctly. Sorry. I mean to say 4. When I have 4 open, then I'm going to have 6 down. So those are some concrete starting out things that we have at our disposal. Sometimes I use gloves, again, for the folding and the flexibility part to show partners of a number, and also any addition or subtraction under 10 and equal to 10. So these are some concrete resources, and I'm going to give you a list of them. These are called tangrams. And all of these are also available virtually. So I'm going to talk about that. But at the moment, these are concrete. And tangrams usually come with a booklet. It's kind of hiding here. And early math development would mean that you use these to make different figures out of these. It teaches you a lot. It teaches you symmetry. It teaches you orientation, how to change how to rotate the shape to actually make it look like something that we're trying to duplicate. And of course, it allows children to have flexible thinking and build something and be creative with it. So these are called tangrams. I have used baking tray, and these are just, that's Play-Doh. And Play-Doh is another concrete material which is so underlooked. Of course, it is to make these circles, but what do we do beyond that? And you can use flour, you can use anything that is moldable. It doesn't have to be Play-Doh. So of course, one of it, and we do it with any language. I have seen people use it for introducing alphabets to actually mold the Play-Doh to make numbers or alphabets, so number formation. But not just that, counting, or the concept of less and more. The moment I can count 1, 2, 3 here, and I can see that I have 3 empty. Maybe I can add 1 more, or I can take away 1 and show some very basic addition subtraction to begin with. I also use this for fractions. Like here, I can show that I have 3 out of 6 shaded and 3 out of 6 unshaded. And also in terms of ratio, I can have different colored Play-Doh, and I can have 3 to 2 or 3 to 3, whatever else I'm trying to show, and how many else I'm trying to fill in here. And then talk about scaling it, maybe using proportions and seeing what would happen if there were 2 trays like this, if there were 3 trays like this. So Play-Doh or clay are good old pulses, beans for basic counting. And that is not just for counting, but also for magnitude. Magnitude simply means that when I say to a very young child, 5, they don't understand what is 5. They will be able to probably count and say 1, 2, 3, 4, 5. Maybe if you've shown them on their fingers, they may also be able to tell you 1, 2, 3, 4, 5. But then if you really ask them what is 5, a good test of that would look something along these lines. Get them to count a quantity and then space it. And then ask them, is it the same? Is it the same quantity? And very young children, even if they understand 5, will have trouble in telling you that this magnitude is the same. The number of blocks that I used in the first row is the same as the number of blocks I used in the second row. So magnitude is very important. It's not just counting. Other concrete materials would be beads, used for addition, subtraction, counting, of course. And of course, our abacus. Again, I use that a lot for partners of 10. As you can see, these are all 10 one side, and I'm showing, so that's 0 and 10, 1 and 9, 2 and 8. So it's not just for counting, but partners of 10, relationships that are numbers that add up to 10, addition, subtraction, multiplication, division, multiples, how to introduce multiplication. Abacus is a really good tool for that. Other concrete materials would be dice, very overlooked again. To show partners of, for example, 6, I'm trying to show 2 and 4, but I can then roll another dice and show them 3 and 3. I can show them 1 and 5. So I'm showing, I use dice to show partners of a number, and of course to introduce addition, subtraction. I use it for doubles to teach like even numbers or doubles. And of course, also my fractions. I sometimes place my dice in a strategic way and put my fraction bar and let them see it as if I had put the 2 on top here, that would be 2 out of 4. I use it for ratios. Sometimes I just put my colon. I have used it for probability, of course. A lot of us do that. And we see this in the textbooks, but actually concretely bringing in these materials to get the children to play around with them is the point of concrete. These are called Unifix cubes. These are also available readily in the market. It's not very expensive. It's about 400-500 rupees that I've seen, good quality ones on Amazon. And I use them for a lot of things again. This is all in elementary, I understand, but sometimes even for remedial middle schoolers, they are very useful. So not just for comparison, more or less, addition, subtraction, all the basic operations. I also use this for plans and elevation. I will show this. If I don't have it right here, I'll probably show you a detailed version of how I do this tomorrow with Unifix cubes using plan and elevation, top view and front view. Moving on, popsicle sticks, using them for tally marks, as well as trying to use it for place value. So one bundle, which I get my students to create so that they can count 5 and 5 and see that that one bundle in the rubber band is showing 10, and then 2 loose sticks to represent a number. I also use it in many other ways. I use my popsicle sticks to not just talk about counting place value, but I also use them to teach angles, to teach the clock. I kind of cut the stick and use it for hour hand and minute hand. I use it to teach polygons. So a lot of building with with popsicle sticks. Any concrete material, anything. These are some bottles of coconut water, and arranged in a specific way. You may use them for so much above and beyond just basic addition, subtraction. I'm arranging them in arrays for my students to see that these are 2 groups of 6, which then is 12. So that is representing 2 times 6 or 6 times 2 commutative property, but also showing 12 divided by 2, which is 6, or 12 divided by 6, which is 2 each. So, and of course, if there is, information at the back, I use that a lot of times for calculations in my class on percentages, decimals, fractions. I sometimes will bring in some other materials and get them to calculate ratios and proportion using the manipulative that I'm using, the physical object that I'm using. If there is some information on how many ml, we do some calculations on, use the metric system. We talk about volume, how many of these are needed to fill like a big container. So a lot of math is possible with physical objects other than the ones I've shown, and sky is the limit there. As we progress, we're also going to look at a combination. So here I don't have the clock, I have drawn the clock. So I'm getting into pictorial, but I will show some concrete materials again. And simple clock like that, of course, it's used to teach time, but not just that, time interval, arithmetic progression right there, modular arithmetic, distance, speed, time, of course, fractions, decimals. A lot of times I am going to draw 1:30, for example, and talk about with my students when, of course, with my first grade, second grade, third grade would be like 1:30, that's 1:30 is 1:30. But then when these same kids reach middle school and you have distance, rate, and time problems, then we have situations where we end up having something where I would say half an hour, and our students get confused on how many minutes would that be? Or if I say 15 minutes, then how do I write that as a mixed number? If I'm saying 2 hours and 15 minutes, a very common mistake is 2:15 or 2.15, which is incorrect. We know that. So I go back to my concrete and pictorial tools to explain that. Money, of course, there is fake money available, and this is called Kingdom of Kids. I think it's a company, and I am not endorsing them. I just happen to have their kit where I use a lot of concrete money. So I don't just use this for teaching money and teaching denominations and decimals or cost. I also use it for algebra and relations and functions. I'll talk more about that as I will progress. I think I addressed this sometime today or tomorrow. And more concrete, some Duplos, These are not Legos. Legos will be smaller than these. And basically blocks that I'm using for distribution. I use them for fractions. For example, this one, I am trying to show that, of course, I can get them to count the number of circles and or get them to see that 2 of these make 1. But also I use it in ways where I will get them to rearrange and see distribution, multiplication, division. And then for measuring the ruler, of course, I'll just put something like a ribbon and get my students to see what is the length of that thing. So I don't necessarily show them everything starting from 0, so that they can see that the starting point here is 5 and this is 15, then how long would that be? Measuring tape, again, a very good tool for measurement, metric system, distance, conversions, and actually physically designing activities in your class to get your students to use these in real time, to do group work, and to actually make use of this to make sense of the metric system or some other math concept. Physically actually using scale for measurement. I also use it for algebra. I will show more of how I employ this in the class. And sometimes to actually get the students to create their own scale, which would be a simple hanger and 2 baskets, and seeing which one's heavier, which one's lighter, and how it will balance. And I also use this to introduce equations sometimes, that it's not balanced right now. This is an inequality, as opposed to how I will add something here or add something here, or take away something from here, or add something here to kind of balance it out. These are called pattern blocks. And these pattern blocks are also something which I use for not just shapes, but also talking about edges, vertices, faces, diagonals, angles, fractions. While I'm sharing all this, I am very much aware, and I have addressed this before, but I would like to repeat that it's not just about these physical objects. All of these are also available in virtual form, and I will share resources on how to, it's all free, and how to actually employ them in your classroom if you are not able to avail these physical resources. I use the same pattern block sometimes to teach symmetry and then show the line of symmetry. I use it for fractions, and then of course, percent, decimal conversions. Nets. When we talk about 3D objects, sometimes it's very hard for our students to really see what that 3D object looks like. So we create nets in our class with paper. We've made a cube here, and then students have gotten even more creative to create some gift boxes. And this was done around Christmas time, so that we could have some ways in which we could transfer our knowledge of math to the real world. So we had some very creative gift boxes, and we actually did some math calculating the surface area, the perimeter just of a face, but then opening it up and looking at the area as well as putting something in it and trying to find the volume. Other concrete materials, of course, our hands, our body. So I have used when I'm making like a particular yoga pose and I show angles. And also, of course, our body is very useful to do some questions related to measurement and height and weight and statistics. Any material. I was eating these cucumbers one day, and I thought of using this as a lesson on introducing concepts and terminology with respect to a circle. And we talked about what the chord was, what the diameter was, what the radius is, how do we find pi, and we actually explored how when I'm looking at the object from top, it just looks like a 2D circle. But actually, if I look at the 3D object, hold it in my hand, I'll see a cylinder with some height. So a lot of math comes from concreteness. A way to use paper, and a lot of paper folding anyway works for so many concepts like translation, like symmetry, like reflection. But I also use paper for a lot of geometry. So here is me trying to show the angle sum property, the relationship of the angle sum property with angles on a straight line. So if I make a triangle and I actually mark X, Y, and Z or any other J, O, Y, joy letters, and then I take my scissor and cut along these sides and then tear along these angles and then rearrange those angles, I'll be able to see that that also forms a straight line, which is 180 degrees, and how the angles of a triangle also add up to 180 degrees. So as I've shown you some concrete examples, how does concrete lead us to pictorial? Pictorial would be a lot of visual representation, and concrete, I am showing you the pictorial representation of my concrete materials, but my concrete materials are some things that we work with our hands. Pictorial would be just the pictures, the visual representations, but it's also beyond that. Sometimes it's diagrams when we're drawing something to explain, when we're using bar models, when we're using graphs and charts. So a lot of these come under pictorial examples, and I will walk you through some of those. And I'm hoping in walking you through these, you're getting ideas on how to employ these. So these are simple dots, and we call this concept subitizing. So I use these dots in different ways to get my students to quickly give me the sum of dots. And that kind of builds number sense in them. For example, once they're able, and dice helps in the beginning, for them to be able to see how that's 5 and 5, 10, and this is 4 and 4, 8, versus this is also 5 and 5, 10, or I can count it differently. I can look at this as 2 plus 6 plus 2. There are different ways to count, and sometimes when they are used to multiplication, and this also it helps in multiplication, when I look at this as rows and columns, and then maybe adding 2 at the top and 2 at the bottom, it builds arithmetic progression, it builds a lot of things. So these are subitizing dots, and these are some things that can just be drawn on the board or on your whiteboard or on a chart paper to kind of take from the concrete unifix cubes and all the physical manipulatives we were using to count to a stage where we are able to quickly look at an image and tell the sum. Another very underused resource is the grid paper. Most math notebooks begin like this, but then we take these away for some reason. Actually using them all throughout till 12th grade is going to be an amazing idea, because there's so much math that comes from the grid paper, and I show a lot of this in my session tomorrow. Pictorial, number line, again, very underused. It's not just for, you can change the scale and start talking about skip counting or your multiplication tables. Of course, it's used so readily with teaching integers and what's going to happen if I had something to the left of 0. So all of that is very useful. And of course, basic counting and multiplication, addition, subtraction, even division comes from the number line. This is the hundreds chart. Just today, I was doing a very simple exercise with a student. I had them circle a number, and they told me that's 45. And this was kind of hidden for them. So then they saw the 45, but they didn't see what was here, 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 or here. So we talked about 1 more, 1 less, 10 less, 10 more. So we were trying to build this understanding of what happens when we add 10 or take away 10 and add 1 versus take away 1. So pictorial. Calendar, again, very underused. It is so useful in doing so much math. You know, not just talking about multiples of 7 or what's going to happen, what's going to be the next Saturday in the month of March, for example, here, or the next Sunday, getting them to think like that. But also there is, again, using the concept of -1 + 1, -7 + 7, and so many other operations and other numerals you can use to build around using your calendar. The grid paper I have used to show place value, where I'm going above my popsicle sticks. So I'm looking at 4 blocks, and I'm looking at 2 10 blocks, and I'm looking at 10 10 blocks. and seeing the 100 and the 20 and the 4 building the number 124. And then sometimes we don't have, or we do have, but it's too tedious. And that's why algorithms and we go to higher numbers to show them that it's not always going to be practical to use concrete materials. And that's why pictorials or abstract is where we are taking them to kind of look at this and be able to tell me that that's 3,452. So that's a 10 bundle, a 100 bundle, a 1,000 bundle, and 3 of them, and 4 of them, 5 of them, and 2 of them. So pictorial then progresses to, I use these for fractions. So I'm moving more into a bar model approach. And I'm going to show you some examples of that today. So here I'm trying to show that this is a whole quantity. Let's say that's a chocolate. And now here's a chocolate cut into 3 parts. So I'm seeing 1 out of the 3, and 2 out of the 3 are not eaten or will be given to someone else. And here I show the concept of unequal, how these are 3 equal parts. However, these are 3 unequal parts. So I cannot call this blue part to be the same as 1/3, as opposed to this green part is definitely 1/3. And then using my Legos to build into fractions, decimals, percents, and time, I just try to sometimes make these structures, and then I put numbers on them to try to show the concept of, okay, that's 1 out of 4, and that's 1 out of 2, and that's 1 full, and how I use conversions like fractions, decimals, and percents to make sense of these Lego blocks. So this is in absence of concrete for the class. You can do it on your own physical or virtual manipulative, and then just take a picture and show it to your class, or actually build it on the board, draw it. All of that is possible in pictorial approach. One beautiful resource that I found, and there are so many, I'm trying to show one on ratios and proportions, is something I found on Matific. And this is building, basically placing birds on the wire. So there are these birds kept, and the wire is initially empty. But then they tell me to do they give me some instructions. So this instruction is the ratio of green birds to blue birds is 6:2. So then if I put 6, if I just go by that instruction and I put 6 and I put 2, I'm lucky here because here I still have 2 for blue and then 3 orange. So I'm able to see that 6:2 to 3 relationship. However, it starts getting more complex. Then they ask me to put something along the lines of 6:2 for blue to green and 2:6 for green to orange. And that sometimes gets confusing for children. Of course, I could have put 6 and 2 for green, and then 2 green, and then 6. But they don't have those many birds. Somehow it restricts you from putting a 6, 2, and 6. So we have to scale it down. To scale it down, I usually use a bar model to explain that when I'm trying to show 6:2, I make a rectangle, I cut it into 8 parts, and I show my 6. What color is that? Blue, and I show my 2 green. And then I can cut it into half again. You can see that dotted line for them to be able to see that that is the same as 3:1. And then it's easy for me to explain what 2:6 would look like. And again, cut that into half, which when I scale it is 1:3. So I'm able to actually show the 3:1 to 3 relationship here instead of 6:2 to 6. Another one, as they increase in complexity, looks something like this: 6:3 for orange to green, but then green to blue is 1:5. So what do we do there? So before these have been put, the explanation is that since we did that 6:3 earlier, we did 6:2, but when we do 6:3, then we're able to see that when we scale that, that'll be the same as saying 2:1. And now that I have been able to scale this to 1, then I am able to make it 2:1:5. Again, increasing in complexity, something along these lines, that the blue to orange is 3:1 and orange to green is 6:2. Now what do we do? How do we place the birds on the wire? So that 6:2, again, making the bar models and showing that when I scale that, that's the same as 3:1. So that would be step 1. But then if it is 3 to 1, then that's the same as 9 to 3, because I'm trying to make this 1 a 3. So I am multiplying both of these with 3 to scale it and make it 9 to 3, which is step 2. And then I'm able to see a 9 to 3 to 1. So pictorial without any resources, without any drawing, without any concreteness, it's so abstract and so difficult to understand for students, for our children, for us. And concrete and pictorial just make it easier for us to make sense of what's happening behind the scenes. Another example of pictorial, sometimes we have these questions in books like even makes even. If I add odd, I'm also going to get even. And we just use numbers. Sometimes I use a lot of paper to show this. That if I actually cut my paper in a way that I have 2 equal halves, I will see that I'm able to see that evenness. And if I have it in 2 odds as well, I'm able to see that evenness. But if I have an odd and even, then I'm not able to see some sort of a square or a rectangle being formed. I'm seeing something beyond that, and that makes that sum odd. Another one for ratios would be a very typical 6th, 7th grade example. Aisha and Bindu share 35 rupees in the ratio 2 to 3. How much does each person get? And I'm going to use bar model to explain. I've already shown you how I am taking my rectangle and cutting it into 5 parts, because these are 2 parts and 3 parts. 2 for Aisha, 3 for Bindu. So AA, BBB. And then I'm able to see, using my bar model, that the 2 out of 5 is out of the full 35. And the 3 out of 5 is out of the full 35. And that's when I'm able to scale it and see that that would be the same as 14 for Aisha and 21 for Bindu. Other pictorial, I think I showed this last time, was distributive property. And I use a lot of algebra with concrete and pictorial, which is something I will discuss tomorrow and a little bit of today, keeping in mind the time that we have. So this was me showing distributive property with the pictorial example, that I have 3R and 4B, which is standing for 3 red and 4 blue for me. And I showed 2 groups of that to show that that's 6R and 8B. And I can't combine it. These are unlike terms. I cannot write this as 14RB or something, where all those common misconceptions and myths that our students have sometimes. Looking at this, they can clearly see it. Yes, they may be 14 and all, but I have 6 red and 8 blue. There's no way I can combine this and write it as one color. Pictorial, there is so much that goes in using a graph for the algebra that we show. For example, this is an equation, 3x minus 2y is equal to -6. And I try to solve for y, and I show my students the working of this equation on the graph, what is really happening. So once I've solved for y, which is isolating the 3x and then dividing both sides by -2 so that y is alone, I'm actually able to see the slope-intercept form. I'm able to see the y-intercept is 3, which is right here on that line, 0,3. And from that beginning point, if I actually get my students to go rise 3, that means climb up 3, and across or run 2 units, they will see this point 2,6. And if I join these 2 points, I'm going to see this line that is being created right here. So more on this tomorrow as well. And to be able to actually see the slope, see the y-intercept from the algebraic representation to the graphical is really important. And I go backwards. I do the graphical and then get them to construct this algebraic equation from the graph. Why are we doing all of this? So concrete materials and pictorial representations are basically linkages to the abstract nature of maths that students see in textbooks. And without the aid of these concrete and pictorial, it's all very overwhelming and confusing. With the use of these concrete and pictorial resources, we are seeing multiple representations sometimes, and we're also trying to make meaning of what is actually happening behind the scene. And yes, we have been taught sometimes without any of these, and it's a very common thing to say, we've survived, yes, but in using these concrete and pictorial representations in today's time, we can actually explain why we are taught certain rules or procedures or algorithms, and how does it really work. And when we know how something really works, we can use it to our advantage even better, not just plugging it in, because if you plug it in, you never know when to apply it. It's almost the same as teaching someone a particular flower, like say hibiscus, in 2D, or just showing you a picture of it, but then a child going around in nature and not being able to identify that flower at all. It's that analogy that I use on why we are using concrete and pictorial materials to teach math as of today, and how useful it is. So when abstract is coming in, what is really happening? We're using so many symbols, equations, formulae, numerical representations, and we're taking away the concrete and pictorial. And that gets hard. But if the concrete and pictorial is there, the connection is going to be seamless. So what does abstract look like? Abstract would mean a lot of things, and I'm going to take you through a few examples. So I could use symbols, and those, when do I use symbols? If I want to say 3 plus 5, I can write it as the numeral 3 and use the plus sign and write 5. And I'm trying to communicate the idea that I'm adding, or I am totaling 3 objects and 5 objects and seeing the sum of those objects. So yes, of course, those symbols help me, but concrete and pictorial will help me connect to those symbols better. So numerals that we're using, they are impossible to understand without the magnitude, as I discussed in the concrete part. Mathematical operations are kind of very hard to understand without understanding what is really happening when we are multiplying and dividing. When we start using things like exponents and superscripts, all of these our high school students start seeing, our middle school students start seeing. It's hard to make sense of this if this has not been shown pictorially or in concretely. Variables, of course, we start generalizing and solving equations, but then it's confusing. So a lot of algebra and a lot of use of algebra I talk about in my session tomorrow. Mathematical notations, such as the following, I talk about. And we use all of these, but if we don't use stories and context, it is all very muddy. We bring in all of this for our students, and then it starts getting even harder when we start introducing Greek letters and function notation, and then go into trigonometric functions. And of course, every time this is taught, it's done without any relevance. This is another thing I want to highlight, even though I'm talking about concrete pictorial abstract and we've gotten past the stories week 1, but also teaching our children where these are used, how these are used, when these are applied. And when are we getting into this mode? What are we really doing here? So all of these abstract ideas are very much made sense of with concrete pictorial. For example, the long division algorithm, if I just give the algorithm straight away to the students, it's a very lengthy process. I start with the dividend and divisor. I'm introducing new terminology, and I just give a list of steps. It's very hard to remember for students. I divide the leftmost digits of the dividend by the divisor. Then I write the quotient above the division bar and multiply it by the divisor. Subtract the product from the dividend and write the result below the bar. Bring down the next digit of the dividend. Repeat steps 2 to 5. Then the final quotient is obtained. It's very hard. It's so hard. And last week, I actually showed you how long division can be taught in a concrete and pictorial way. And I'm reminding you of that Asha has 48 cookies and she puts them equally in 5 trays. And I'm giving a story, I'm giving a context, and I start showing. I had used 10 frames to show this, that if I have 48 and I label them as A, B, C, D, E, A, B, C, D, E, I will be able to do that 9 times. And I will be able to see that I will be having 5 trays. I'm sorry, I'll be able to do that 5 times 9. And I'll be seeing 9 cookies on those 5 trays, and I'll see 3 cookies left over. So this is when you're showing it pictorially. And you can use concrete materials to actually do it in person so that it's really understood by students what is really happening when we're doing long division. So all these abstract notations, and there's also this thing about mental imagery this is possible only with concrete and pictorial coming in progression and leading into abstract. And when it leads to abstract, of course, because of concrete and pictorial, we are seeing better memory. It aids in encoding, better recall by students and retrieval of information. They're better able to make connections between a previous concept and a new concept. We will see better problem solving. We will see our students to be able to mentally manipulate objects in their head and be more adept at exploring different solutions. We'll see more creativity. We'll see much better learning and comprehension because of that enhanced understanding and retention of concepts. So overall, from concrete to pictorial to the abstract stage, that progression in today's time is very relevant. Our students are exposed to so much visual stimulus, and using that to our advantage is our job in today's time. So mental imagery for this kind of a picture would have been, if they had seen this, for them to be able to say that, well, what am I trying to do here? Maybe I have 32 pencils and I'm dividing it among 4 people to be able to see that that's 8 pencils per child. Mind maps and concept maps are all abstract ideas. Mind maps would look something like the following. I'm teaching quadrilaterals and I'm trying to kind of just break down and brainstorm ideas on what all is going to go in the chapter. Concept map will be a little more detailed, where I write down the properties of each of these. So what's missing in the mind map that I've given to change this to a concept map, which is an abstract idea, would be to have diagrams, to have formula, to have definition, to have properties. If you look closely, all of this is pictorial. So when we are teaching abstract, we are trying to go back to pictorial. So it makes sense to actually go in order and do concrete, pictorial, and then abstract. So overall, what are we looking at tomorrow? We are looking at more concrete, pictorial, abstract in action. And I will show some detailed ways in which I'm using it for, I'll show some very specific concrete and pictorial and abstract materials that I use in my classes. And I'll show the range from K through 12. And we'll do a little bit of a recall and a summary of whatever we've done in the past few weeks together. And we'll discuss our takeaways from this. At the moment, I will leave the floor open for a Q&A. And Saryu, if we are ready, maybe we can even do the opinion poll to get a sense of what our teachers are still hungry for that I can possibly address tomorrow as well. Do you think that's going to be possible, the opinion?
Hi, very interesting session, I must say. First, let's ask some questions. If anybody wants to ask any question, the chat box is open.
Thank you for that feedback, Saryu. We are now looking at anyone with any questions. Thank you for your feedback. So Singapore bar model, I showed some examples. I will be showing some more examples tomorrow, Kamakshi.
I think everybody is finding it an interesting session. In fact, I must say, very interesting, Jaspreet ma'am, and the concrete objects, that a variety of objects you have suggested that we can use in our classes, both for the concrete and for the pictorial, because normally our classrooms are chalk and board, that is more of an abstract, but very nice. And my favorites are like tangram is definitely one of my favorites, Play-Doh. And I'm sure everybody here has a takeaway. And thank you so much. I'm personally also looking forward for this last session, that is the 6th session. And for teachers also, I would like to say that tomorrow is going to be our final session, that is the 6th session. And after that, we are going to have our quiz. So try to attend all of them and you can be the winner of the exciting prizes. And thank you so much. We'll meet tomorrow along with the opinion pool for tomorrow, right?
All right. Okay.
Thank you so much.
Thank you, everyone. I am looking through some of the
Have a-
questions that have been
Yes,
shown,
is it?
that have been
Yes.
asked. I just wanted to address a few of them if I have been able to quickly scroll through the chat.
Yes, ma'am.
One of them was to do with LCM and GCF. Well, I love to use Venn diagrams a lot. And I use concrete materials in the sense that, for example, when I'm talking about LCM, what is least common multiple really? I mean, of course, sometimes we show it to our students with showing that if I have all the multiples of 8 listed, and I have all the multiples of, say, 2 listed, then the least common multiple would be, at this point, the lowest common multiple, which is that. But so that right there, you're using pictorial. Concrete could be to do it with objects, to actually do 2 objects and 4 objects and progress and see where the numbers are actually meeting. I do this with a story as well. I say, well, we have a student who exercises every 8 days, and we have a student who exercises every 2 days. And today is the day that they've exercised together. When's the next time that they'll exercise together again? So when you put it in terms of a context, when you have a pictorial representation, you are using your, you are teaching it that way. Venn diagram, there are so many ways in which there is a way to be able to see that the intersection, if I list all the factors of a number and I list all the factors of another number, and I'm able to actually see then what is really happening. If I do prime factorization, for example, if I have, I'm trying to think of a number, say I have the number 30, and I have the number 75, let's say, and I'm trying to look at all the factors of 30, and I put that in the form of my Venn diagram, then I'm going to be looking at something along these lines. So I'm going to list my factors. Let me erase so my factors are 2, 3, 5. And I'll see those common factors here as well for the 75, which is 3, 5, 5. And if I see my intersection, that is my GCF, or my greatest common factor, 15. So there's so much that is coming from pictorial. And it's not just about, I mean, of course, you need to be educated on these, and that's why I'm here. And I'm very happy that you're asking these questions. And for all of the concepts, there is a way to start with concrete and abstract, concrete and pictorial to reach the abstract. Somebody said, how about for calculus? Well, for calculus, everything when we are trying to show turning points, maximum, minimum rate of change, we are using a graph, and that is a pictorial representation. And that's how we're making sense of that equation that we're looking at, for which we may be finding the derivative. There's a story that may be useful. For lack of time, I will not share this right now, but you can actually Google it. And if you have time tomorrow, I would love to tell you on how I introduce calculus, which is using Zeno's paradox. So Zeno's paradox is a beautiful way to introduce calculus. And then, of course, everything, if you've taught concrete pictorial so well, calculus will be a breeze. It will. But it comes with a lot of good teaching in the primary and the middle years. There's a big responsibility for those ages to teach than to actually put all the burden on our high school teachers. Another really quick one I was seeing, if I have not missed it, is this thing about somebody had mentioned. So I talked about LCM, GCF, and I'm just trying to scroll through the chat. Bear with me one second. There was somebody mentioning HCF, LCM. We talked about algebraic expressions. We talk about that tomorrow. Polynomials also, we talk about that tomorrow. We talk a lot of algebra. You'll see a lot of algebra in use for high school tomorrow. I want to, I'm just trying to scroll back and see there was somebody, who's spoken about exponents and powers. A lot of concrete and pictorial happens with exponents and powers. A lot of paper folding. For example, one paper right here, and if I fold it, I give one fold to it, I'm seeing 2 parts. If I give 2 folds to it, I'm going to see the 4 parts. So it's a nascent understanding of that. But above and beyond that, also to look at it when we teach all the properties of exponents, when you're teaching this to your students, for example, to actually just open it out, to let them see that that is repeated multiplication of 5 8 times, as opposed to repeated multiplication of 5 3 times, and to be able to see that that is gone because that is a 1, and I'm left with 5 to the power of 5. So a lot of visual representation, if it's not concrete, it is pictorial. So that's why knowledge of, if you'll see it really in theory, how it's working is with very strong concrete understanding, children are able to make better sense of pictorial representations, which helps them make better sense of abstract math. So that's it from my end for today. And I will see you all tomorrow and take on more algebraic work and a lot of other questions that I saw here, which will be addressed tomorrow. So thank you so much.
Thank you so much, Jaspreet ma'am. And we are looking forward for tomorrow's session. That's the final session. And for the quiz as well that we are going to put.
Sounds good.
Yeah, till tomorrow.
Myself. Thank you.
Yeah, thank you and have a wonderful evening. See you tomorrow.
Thank you, everyone.